Good afternoon everybody. So in this video session we are going to learn about improper integrals of first and second kind. So improper integrals of first and second kind. This is the learning objective. These are the session outcomes. These are the prerequisites. So let us define improper integrals of first kind. So an improper integral with finite interval of integration AB with its integrand having finite number of points of infinite discontinuity is known as improper integral of first kind. Or in other words, we can say that if suppose that in an integral from a to b f of x dx, either both the limits a and b are infinite or any one of them is infinite, but f is bounded, then it is known as improper integral of first kind. For example, now in this integration from 1 to infinity dx by root x is an improper integral, because here one of the limit, that is the upper limit, is infinity. Upper limit is infinity. Similarly, in the second problem, it is also an improper integral where the lower integral is infinity and e raised to 2x is bounded function. Here also 1 by root x is bounded function. But in the third example, here both the limits are infinite. Both the limits are infinite and 1 by x square plus 2x plus 2 is clearly bounded function. So therefore, these are improper integrals of first kind. Next, we go to improper integral of second kind. So if in the definite integral a to b integration from a to b f of x dx, if both a and b are finite, so that the interval of integration is finite, but f has one or more points of infinite discontinuity, then integration of a to b f of x dx is called improper integral of second kind. Or in other words, we say that if in the integral a to b f of x dx, if both are finite, if both the limits a and b are finite, but the function f is unbounded, okay, it is not bounded, so then the integral is said to be an improper integral of second kind. For example, now in this example we see integration from 0 to 1 dx by x square. Now in this case both the limits are finite, okay, both the limits are finite, and but here the function 1 by x square, what happens, 1 by x square as x tends to 0, it gives 1 by 0 which is infinity, so f is not bounded. F is not bounded. And similarly in the example, second example, in the integral both the limits are finite, 1, 2, both the limits are finite, but the function 1 by 2 minus x is infinity when x is equal to 2. When you substitute x is equal to 2, then it gives 1 by 2 minus 2 means 0, 1 by 0 is infinity, so f is unbounded or f is bounded, but both the limits are finite. Both the limits are finite. And similarly here both the limits are finite, and for the value of x equal to 1 and for the value of x equal to 4, this 1 divided by x minus 1 and 4 minus x gives infinity. So therefore here f is bounded and the limits are finite. Here also f is unbounded and the limits are finite. Here also f is unbounded and the limits are finite. And in the first example also both the limits are finite, but the function f 1 by x square is unbounded. So therefore these are the examples of improper integral of second kind. Next we move on to evaluation of improper integral of first kind. How to evaluate the improper integral of first kind? So when the improper integral is of first kind, that is either a or b or both a and b are infinite but f is bounded. Okay, then we define integral from a to infinity f of x dx is equal to limit as t tends to infinity integration from a to t f of x dx where t is greater than a. Okay, so in this case the improper integral a to infinity f of x dx is said to be convergent if the limit on the right hand side exists finitely, and it is said to be divergent if the limit is plus infinity or minus infinity. If the integral is neither convergent nor divergent, then it is said to be oscillating. Okay. Next, in the second example, the integration from minus infinity f of x dx is equal to this integral can be taken as limit as t tends to minus infinity integration from t to b f of x dx where t is less than b. Now the improper integral integration from minus infinity to b f of x dx is said to be convergent if the limit on the right hand side, means here if the limit on this right hand side exists finitely, and it is said to be divergent if the limit is plus infinity or minus infinity. Okay. Similarly, when the integral is of second kind, both a and b are finite, but f has one or more points of infinite discontinuity. So in that case, if f of x becomes infinite at x equal to b, say if the function f of x becomes infinite at x equal to b only, then integration from a to b f of x dx is taken as limit as epsilon tends to 0 plus integration from a to b minus epsilon f of x dx. Further, the improper integral a to b f of x dx is said to be convergent if the limit on the right hand side exists finitely, and it is said to be divergent if the limit is plus infinity or minus infinity. Similarly, in second, if f of x becomes infinite, suppose if f of x becomes infinite at x equal to a only, then integration from a to b f of x dx can be taken as limit as epsilon tends to 0 plus integration from a plus epsilon to c f of x dx. Now in this, the improper integral a to b f of x dx is said to be convergent if the limit on the right hand side exists finitely, and it is said to be divergent if the limit is plus infinity or minus infinity. So with this chapter I conclude my session and continue in the next class. Thank you.